All right, let's do this. I'm gonna wait for a little more people to get in. Okay, we don't have anyone else yet. Hopefully, these messages get somebody. Oh, let's go. www. All right, Ayaz is here. Is that how you say your name? Is it Ayaz or Ayaz? I've only ever seen it like written, like in the chat. I'm gonna guess Ayaz. Ayaz, let's go. Or what is the first one I said? I've already forgotten. Probably Ayaz. Okay. Well, more people will come in as we go, but it's just you and me, I guess. Let's do some calc. All right. So number 40 isn't calculus, but they start at number 41. I just needed to include number 40 to have the graph in here. All right, this says find the area bounded by the graph of the right branch of the hyperbola and the line x equals 10. So x equals 10 is going to look something like this, and if it's bounded by the hyperbola, we're basically just finding this area. Okay, so first thing we have to do is we have to find the equation of the hyperbola, right? So since it's facing horizontally, the equation of our hyperbola is going to look something like this. It's going to be x squared over a squared minus y squared over b squared equals 1. This is just like the general form. And it's just x and y, not like x minus stuff, because we can see that it's centered at the origin. Right? We're centered at the origin, so we just have to deal with this. So, well, we still have to figure out what this equation is, or else we're kind of stuck. Well, a is just the distance from the center to one of the vertices. We can see that distance was from 0 to 6. And so we're going to have a equals 6. So this is our equation so far. B squared equals 1. But we still don't really have our equation, but we can solve for b because we're given these points. I'm going to use this point. We're given the point at x equals 10, y equals 4. So we can use that to solve for b. So x is 10, so that's 100 over 36 minus 16 over b squared equals 1. And 1 second, let me solve for b real quick. Okay, we get b squared equals 9. So the equation of our hyperbola is x squared over 36 minus y squared over 9 equals 1. There you go. That's the equation of the hyperbola. So find the area bounded by the graph. So what I'm going to do, I'm going to get this in, so y in terms of x, right? So that's not going to quite give us a hyperbola. What it's going to give us instead is this. If I take the positive, it'll give me that. If I take the negative, it'll give me the other, right? But if I can get y in terms of x, then I can just integrate from 6 to 10, and then at the end it's symmetrical, so I can just double it. So if I'm solving for y, I'm going to use positive. It doesn't really matter. But I'll get, let's see, y squared over 9 equals x squared over 36 minus 1. And then multiply everything by 9, so y squared equals x squared over 4 minus 9. And I'll get y equals the square root of x squared over 4 minus 9. Sweet. So now I can just integrate this, because, okay, so that's what this equation would be right here. Now I can just integrate this, because I'm bounded by the right branch, so I'm integrating from 6 to 10 of this equation. And that gives me this area. And then if I want the total, then I just have to multiply it by 2. What do we get? I'm doing this in my calculator, by the way. I don't really want to do this by hand. And you get 20.2? Nice. 20.2. Sweet. That's it. Let's move on. Oh, I went to the wrong thing. Here we go. By the way, if you notice that I make a mistake, I haven't looked at this test like pretty much since I took it. So if you notice that I do something weird that you think is probably wrong, then you're probably right. It's probably my mistake. So just let me know. Okay, a 50-foot ladder is leaning against a building. If the base of the ladder is being pulled away from the building at a rate of 4 feet per second, then the top of the ladder will move down the wall at a rate of how many feet per second? At the moment, the base of the ladder is 14 feet from the base of the building. Okay, so always draw these just because it makes the whole process easier. So this is the floor, here's the side of your building. These are supposed to be perpendicular, I just didn't do a very good job of drawing it. Here is your 50-foot ladder. So I'm going to call the distance from the bottom of the ladder to the wall A, and I'm going to call the distance from the corner to the top of the ladder, I'll call that B. Right? So it's a 50-foot ladder, so this length is 50. That's a constant. The base of the ladder is being pulled away at a rate of 4 feet per second. So you can write that as dA dt, right? The rate of change of A with respect to t equals 4 feet per second. And actually, I'm just going to write 4 because all of our units are in feet and seconds. Then the top of the ladder will move down the wall at a rate of, okay, so we're trying to solve for dB dt. We don't know what this is, but we're trying to solve for it. We want to find it when the base of the ladder is 14 feet. So we're trying to find it when A equals 14. So this is like a related rates problem. Well, it's not like it is a related rates problem. So you basically, when you solve these, you want to find some way to relate all the variables that you have to deal with. So realistically, the only two we have to deal with are A and B. So we have to find some way of relating these. And the one that comes to mind first, there's probably multiple ways of doing this, is the Pythagorean theorem, right? A squared plus B squared will equal 50 squared, right? So if I take the derivative of both sides with respect to time, the derivative with respect to time of A squared will be 2A, and then I got to multiply by the chain, right? Because I'm taking the derivative with respect to t, but A squared is in terms of A's, right? So I have to multiply by this dA dt out front. And then same logic for the B. And then the derivative of a constant is just going to be 0. To simplify a little bit, I'm just going to cancel out the 2's, divide everything by 2. And I get this equation. So A times dA dt plus B times dB dt equals 0. So do I have all the information I need? Well, I have A is 14. I have dA dt equals 4. I don't have B, but I can solve for it because the hypotenuse is 50 and the base is 14. And so my b is just 48, right? Just with the Pythagorean theorem. So my b is 48. I don't know my dB dt, and set that equal to 0, and I get dB dt equals negative 7/6. Oh, it's moving down the wall, so it's just 7/6. Nice. Let's keep rolling. Oh, crap. Oh, I forgot. I should link the test in the description. Give me 1 second, guys. Hopefully that worked. Okay. Let's go to the next one. Okay, consider the graph of f of x equals 3 sine of x plus 2 cosine 2x. How many values of x exist in the interval 6, 10 such that there's a horizontal tangent at x? Okay, so if there's a horizontal tangent, what that means is that the slope of your tangent line is equal to 0. And in calculus land, we know what this means. This just means that, says that link will not, yeah, I kind of suspected that that wouldn't work. Let's see, what else can I do? Because it's not a hyperlink, it's just like a straight. Oh, because it's my downloads. That's why. It's not a web link. I wonder if I can. Actually, I might want to steer away from that. Okay, sorry, that's not going to work. I can't exactly just take screenshots, because I'm not sure if I'm allowed to do that, because you technically have to pay for these. You need to upload it to. Yeah, yeah. Next time I'll upload it to Google Drive. Okay, I know that for next time. That's okay. All right. Anyway, with this problem, so consider the graph. Yes. So we're basically just trying to find when the slope equals 0. Which in calculus line we know just means find when the derivative is equal to 0. So if I take the derivative of this equation, right? The derivative of 3 sine of x is just 3 cosine of x. Then the derivative of 2 cosine 2x is negative 2 sine of 2x. And I'm trying to find when this is equal to 0 on the interval from 6 to 10. Oh, didn't mean to do that. On the interval from 6 to 10. So there's a way you can do this on your calculator, because to be honest, this is kind of an annoying solve to do by hand. So I'm going to do 3 cosine of x minus 2 sine of 2x. That's what it was, right? Let me double check. Yeah, that's right. Equals 0. And when you do this, you get you basically get infinite number of solutions, which makes sense, right? Because sines and cosines are periodic, it's going to keep repeating. So what I can do is I can go up here and actually set bounds on my equation to find the values that are just between 6 and 10. Did I forget to multiply by the 2 originally? Oh my gosh, yeah, you're right. I multiplied by the chain, but I didn't see this part. That's like the opposite mistake that people usually make. Yeah, you're right. It is 4 sine of 2x. Yeah, multiplied by the chain, but not by the coefficient. That's interesting. All right, here we go. So when I do this, I get all my values. So the question just wants to know how many values there are. It doesn't really care what they are. So I have one at 6.67. I got one at 7.85, and I've got one at 9.04. So that's 3 values. Nice. Okay. Yeah. Thanks for catching that. That would have been interesting, like looking back and being like, wonder what I did there. Okay, find the average value of f of x equals 2 sine x plus 5 cosine x in the interval from 6 to 8. Okay, so this is just a formula, basically. Um, it comes from the idea that, let's say you had a graph, and this isn't actually the graph of this. This is just like an arbitrary graph. And say this is at A, this is at B, and you're finding the area under the curve, and you want to find the average value, right? So those of you that have taken calculus are like familiar with the idea of like the area under the curve being the limit of like a bunch of rectangles. And so what you can do is if you find the area, you can say that that's equal to the length of your interval multiplied by your average height. Right. And your average height, and that's the same thing as your average value. So the way you write this is average height would be average value. The length is just the length of this interval is the difference. So that would be 1 over b minus a. One side subtracted to the other side. And then my area, of course, is just this integral of f of x dx. So in this case, right, our length of our interval is from 6 to 8, so that's just 2. Then it's integral from 6 to 8 of 2 sine x plus 5 cosine x. And I'm just gonna type this in. So 2 sine x. Make sure you're in radians if you're following along. Yep, and you get 4.27. So 4.3. Nice. Okay. Hopefully this idea right here made sense. The area equals length times average height. Yeah, that's how I like to think about this problem. Okay, I think we got a differential equation next. Yep. Oh, it's like a two-parter. Sweet. All right, let's see. Let f of x be the solution to the differential equation dy dx equals x over 2y with the initial condition f of 4 equals 3. Use Euler's method to approximate y of 5 using two steps of equal size starting at x equals 4. Okay. So if you're not familiar with Euler's method, this is the way that I usually like to do it. I make a table. So in one column I have x, one column I have y, and in one column I have dy dx. So I'm starting at an x of 4, right? It tells me f of 4 equals 3. And then I have two equal step sizes. So my other two x's are going to be 4.5 and then 5, because that's where I end up, right? Y of 5. At x equals 4, I'm starting at 3, which means that at x equals 4, the slope of my line, or the slope of my tangent line, the way I'm approximating this, I can calculate it through here. So it would be 4 over 2 times 3, which is just 2/3, right? So if the slope of my tangent line right there is 2/3, then how much, if I increase my x by 0.5 to get to 4.5, how much is my y going to increase? Well, that's just going to be 2/3 times 0.5, right? So my y is going to be 3 plus that, which is just 3 1/3. Right? Okay, now let's see what my dy dx is right here. So it's going to be x, which is 4.5, over 2 times y, which is 3.333. So my dy dx right here is 0.675. Well, if my dy dx is 0.675 and I increase by 0.5, then that's going to add the slope times my interval to my y. So I'll add 0.675 times 0.5 plus 3.333, and I get 3.6708. So I get D. You might think that this is a little bit slow, and it definitely is for whenever you get more intervals. So there's actually a way to do this on your calculator. That if you get fast at it, it saves time, but it's really up to you if you want to use it. So what you're gonna do, you're just gonna type the word Euler for Euler's method. The next thing you do is you just type whatever dy dx is equal to. So in this case, that's going to be x over 2y. Then you do comma x comma y. That's basically if your independent variable, then your dependent variable. Then I'm going to make a list, and this list is going to have two things. It's going to have your starting x value and your ending x value. So in this case, we start at x equals 4 and we end at x equals 5, and so that's going to be what's in the list. Then your next one is just what's your starting y value? What's your starting output? And we can see from right here, we're starting at y equals 3. So comma 3, and the last one is our step size, which if you're going a distance of 1 and you have 2 steps, then our step size is going to be 0.5. And you can see it outputs this table, and this is the exact table that we have over here, It just doesn't have the dy dx, right? So at 4, we're approximating it to be 3. At 4.5, you'll approximate it to be that. At 5, you'll approximate it to be that. Right? And we get the same thing. So it's up to you if you think that's faster. It really is just preference. But yeah, let's go to 46. So now we need to find the exact value of y of 5. And for this, we're going to have to actually solve this differential equation. So to do this, you're going to use a tool called separation of variables, where basically you just want to get back all your y's and dy's on one side, and all your x's and dx's on the other. So if we have dy over dx equals x over 2y, then separating the variables would look like this. So I'm going to move the y's over here, right? 2y dy, and then all my x's to the right side, which would just be x dx. Now, if I integrate both sides, right, here we go. If I integrate both sides, the integral of 2y with respect to y is y squared. Don't forget to add your plus c. And if I integrate x with respect to x, that gives me x squared over 2, and then plus c. But if I have a plus c on both sides, then when I subtract the other one over, it's basically going to end up, well, actually, let me show it this way. If I make this plus c1 and this is plus c2, right? And then I'll subtract the c1 over to the other side. Right? Constant 2 minus constant 1 is still going to be a constant, so I'm just going to write it as a c. That's what I was trying to say earlier. So this is the solution to our differential equation. Except we still have this constant, which is leaving us a little bit like in the air right now. So what we can do about that is we have this initial condition up here, which tells us when x equals 4, y equals 3. So we can use that to solve for what c is. So if I just do that really quick, you get c is equal to 1. And so the solution to our equation is y squared equals x squared over 2 plus 1. Well, what does it actually want to know? It wants to know what y of 5 is. So when I plug x equals 5 into this, it wants to know what y comes out. Well, that's pretty easy. You just plug in 5 and solve for y. So it's going to be the square root of 25 plus 1. You should get 3.6742. There you go. Nice. Let's keep going. If one of you is like just joining me, or I say something that doesn't make sense, or I make a mistake, just leave a comment and I will I'll go back over it. If you're getting here and so say you just got here and you wanted to see number 42, but I've already done it, you can either go back and see what I did, or if you go back and you're like, oh, this doesn't really make a lot of sense, text it in the live chat, and I'll go back and do it again. I'm not erasing any of the problems I do for that exact reason. All right. Let's keep going then. Oh, we got another two-parter. These two-parters really save you time on math, I'll tell you that. Yeah. You're hoping for as many two-parters as you can get. All right, let's see. 47, 48. Consider the region bounded by the graphs of y equals 0.5x squared and y2 equals 4 minus x. All right, we want to find the area of the specified region. Okay, so this is your pretty essential calculus problem. I'm going to go ahead and graph this. You wouldn't normally do this, but just for the visual, I think it's a good teaching tool. So I'm going to have to remind myself what they actually were. 0.5x squared and 4 minus x. There we go. Okay, I'm going to zoom out a little bit. Well, anyway, okay, so now you can see this bounded area that they're talking about. So the way you do this is you first have to find the intersection between these two graphs, because once you find the intersection, then you can use those as the bounds of integration for finding the bounded area. So 0.5x squared, 0.5x squared equals 4 minus x. Solve that, and I get x equals -4 and 2. You probably could have solved this by hand, but just for time's sake, you wouldn't always know that in advance. And saving time is good whenever you have 60 problems in only 40 minutes. All right, so these are your two bounds. You got -4 and you've got 2. Okay, so if we want to find the area bounded, all we have to do is just integrate between these two values. You could figure out like which one is greater and which one is lesser to make sure you get a positive value. But in the end, you know that you're just going to take the absolute value of whatever you get. So I think the graph showed that y2 is bigger on this interval. So if I just do this, if I just integrate this, I should get the correct bounded area. Yep, and I get exactly 18. That's pretty satisfying. Nice. All right, so 48, find the volume of a solid generated by revolving the specific region about the x-axis. Okay, for this we're going to use something that I like to call washer method. And the reason for that is let's see if I can draw this graph. Drawing graphs is probably not my strong point, but that wasn't too bad. And then 4 minus x would look, something like this. Yes? Okay, so that's -4. That's 2. And pretty much, whenever you're finding the area of a volume, it's helpful the same way that when you find when you're finding an area like with a definite interval, you can split it up into rectangles. Finding the area of something revolved, you can split it up into a bunch of circles, or in this case, disks. So, let's say I take this part right here. If I revolve this point about the x-axis, it'll look something like that. And this is 3D. Keep in mind, it's kind of hard to draw, but hopefully you get the idea. And then, so I have that disk, and that's like a solid disk, right? But you have to remember that I'm not covering this entire area, right? I have this other function here that's like cutting some of the stuff out, and so I'm gonna get this little circle in here, and this is why it's called washer method, because you see, for each point, for each x value, you're gonna get these washers. And so you can imagine that for each for each x value, the area of one of these washers is, or the volume of one of these washers is going to be the value of the function at x. Sorry, not x. The value of the function at x for 4 minus x, right? Because that would be the radius of this disk squared times pi, and then I have to subtract out this little one, which would be pi times 0.5x squared. And then I want all of these disks from -4 to 2. If I really wanted, I can factor out this pi. It doesn't save that much time, but if you've seen this kind of question before, then I guess it would add up. And then I just have to evaluate this, which, calculators are made for something. And when I do this, I get a value of 362. Oh, I forgot the dx. Yes, there you go, dx. You get 362. Yeah, this is called disk method. You can find a similar explanation to this. I kind of stole that explanation from Khan Academy. That's where I learned this. But yeah, let's keep going. Are we almost to the stats? Oh, there's not a lot of stats on this test, actually, compared to some of the others. All right, here we go, 49. All right, so 49. If piece of 3 of x is the third degree Maclaurin polynomial for f of x equals e to the x, then f of 0.5 minus piece of 3 of 0.5 equals what? Okay. So for those of you that don't know, a Maclaurin polynomial is basically just a way of using derivatives to approximate functions. I mean, that's like long story short. It's used to approximate functions that otherwise are just annoying to work with. So, I'm pretty sure that the Maclaurin polynomial for e to the x is something like, it's like 1 plus x plus, yes, it's this. Yeah, I'm pretty sure. And, I mean, it's pretty easy to see where this pattern is going. But yeah, if you expand this all the way out, then you would technically get an exact approximation for e to the x. But what this is saying is it's a third degree Maclaurin polynomial, and so we're just going to stop. We're going to stop right here, right? Because here's where our x cubed term is. That's the third degree. It's the fourth term, but it's the third degree, right? And there's a few ways you could find this. A lot of people will just memorize them. There is a formula to go about calculating these on your own, but that's a little bit outside the scope of this question. One way you could do it, if you forgot what it was, and this will actually test if I know what this is you can go to Menu, and then Calculus, and then down here C is for Series, and then Taylor polynomial. And what you do is you just type e to the x, comma x, and then whatever degree you want. So there. Yep, okay, so I was right. And that tells you the third degree Taylor polynomial of this right here, of e to the x. So what it's asking for is basically just saying, oh, I want to plug 0.5 into the exact equation, then plug 0.5 into the approximated equation and find, well, what's the difference there? So it's saying e to the 0.5 minus 1 plus 0.5 plus 0.5 squared over 2 plus 0.5 cubed over 6. And it might actually surprise you how small this difference is. These Taylor polynomials are really impressive. If I do this, I get 0.0029. Yep. There we go. So hopefully that concept kind of made sense. There's a lot more going into that that's outside the scope of this question, but long story short, it's basically using derivatives to approximate the function. I'll always endorse Khan Academy because that's where I learned pretty much all the calculus that I know. But yeah, he has a really good video explaining like how to derive these Maclaurin polynomials, if any of you want to check that out. Okay. All right, the position of a particle is given by the parametric equations x of t equals 3e to the 4t, and y of t equals natural log of t cubed plus 3t minus 2. Find the velocity vector when t equals 3. Okay, so the velocity vector is basically just finding, if our position vector is x of t and y of t, then our velocity vector is basically finding dx dt and dy dt, right? How fast is y changing? How fast is x changing? Or, shoot, I flipped those. But you know what I mean. How fast is x changing? And how fast is y changing? Well, luckily, this is actually pretty straightforward to solve, because all you have to do is take the derivative of both of these and then plug in your values. So, if I take the derivative of x of t, derivative with respect to time of 3e to the 4t, that's going to give me, okay, I'm going to get the chain rule right this time, guys. It's going to be 12e to the 4t. And then if I do this for my natural log, pretty sure the derivative of natural log is yeah. So let's see. This is going to be, it'll be 1 over this whole thing, and then multiplied by the derivative of what's inside, which is going to be multiplied by the derivative of what's inside, which would be 3t squared plus 3. So this right here, this is dx dt, this is dy dt. And we just have to find it whenever t equals 3, which is pretty straightforward. You just plug in 3. So our x will be, if I plug in t, that's 12e to the 12th. So that's not b, not d. And then I just have to plug it in here. So 3t squared will be 27 plus 3 is 30. And then 27 plus 6 is 33. What did I do? 27. Oh, 27 plus 9 is 36. Minus 2 is 34, which gives you 15 over 17. So that's answer choice E. Nice. Yeah, that's pretty straightforward. I mean, if you have x of t and you have y of t, just take the derivative of both of those, and that'll give you your velocity vector. Nice. Okay, what does 51 look like? Ooh, I have to refresh. Yeah, 51 is B. That's what I thought. All right. The second derivative of a function h of x is given by h double prime equals x squared times x minus 2 cubed times x minus 8 to the 5th. Okay, of the following values of x, which of these does the graph of h of x have a point of inflection? Okay, so this is a little bit of an uncommon concept. Usually when you say, what's the point of inflection, you say, when is a second derivative equal to 0? But in reality, the point of inflection is when the concavity changes, right? It changes from positive to negative or from negative to positive, right? So here's an example. Let's say instead of h double prime of x equals all this, let's say it was just x squared. Let's say it was just x squared. You guys know what x squared looks like, but I'm just doing this for the demonstration. So I'm approaching on the negative side. I'm getting closer and closer to my point that's 0. I have positive inflection, right? And then I hit my 0, right? This is where my concavity would be 0, right? But instead of changing to negative, I'm actually going back up. And so yes, I have a point of 0 concavity, but it's not a point of inflection because I'm still remaining positive. So you can imagine that, right, if you plug in a negative number and a positive number into something with an even power, right? It's going to stay the same side. It's going to stay positive. You plug it in with an odd power, right? If I do -2, what is happening? If I do -2 cubed and I just do 2 cubed, right? Because this is an odd power, it's going to give me opposite signs, which means, this means that I not only have a point of zero concavity, but I actually have a point of inflection. And so the ones that have a point of inflection are going to be right here at x equals 2 and right here at x equals 8. Okay. And last calculus one. Hopefully you guys are sticking around. I saw we had 4 at a time at one point. Alright, 52. The graph of the piecewise function f of x is shown on the right. Find the value of integral from 0 to 10 of f prime of x dx. Okay, so some of you might already see what's going on here, but I'm just gonna carry it all the way out. Anyway, so if I take the integral with respect to x of f prime of x, that's just going to give me f of x, right? They're just inverses of each other. And then I have to evaluate this from 0 to 10. Well, that's just the same thing as f of 10 minus f of 0. The graph tells me f of 10 is equal to 4, tells me f of 0 is equal to -2, and so this integral is just equal to 6. This question's actually really easy if you just see it. I mean, aren't all of them? If you know what to do, then they're easy. Yeah, thanks. I should say it's a really quick problem if you see what you have to do. All right, we are moving on to the statistics. I'm actually going to send this out. Here we go. Misspelled statistics. And I misspelled the. That's impressive. Okay. Did I already do this? I can't remember. This is another two-parter. This one doesn't look too bad, though. Okay. Use the table for problems 53 and 54. Okay. Phoenix entered the Erie County Bowling Marathon last week. Each contestant is required to bowl 9 games in 6 hours. The table above shows the results. What's the difference between the mean score and the median score of a positive number? All right, so for the sake of this one and the next question, because I'm already seeing interquartile range, I'm going to list all of these in ascending order. So I'm going to get 144, and then I'm going to mark these off as I go. 154, 166, and I got 172. I've got that twice. And then 188, 198, 205, 221. There you go. That's 9, right? Yeah, okay, so that's all 9 of them. So what's the difference between the mean score and the median score? Okay, so you can see from this, the middle number is 172. That's pretty easy. The mean score it's just as easy. It's just you have to type it in this time. And then divide by 9. So you just add them all up and divide by 9, right? And you get a mean score of 180, and so the difference between those two is just 8. Now we want to find the interquartile range of the scores. So when this happens, right, you yes. Pretty much you ignore the median. So you're not counting that anymore. Basically, you're finding the median of the left and you're finding the median of the right. And so you have an even number on both sides. So from 154 to 166, halfway between those is 160. And then from 198 to 205, halfway between those is 201.5. And so subtracting those two should get a C. Yeah. Let me double check that because I'm I have a feeling I did something wrong, but maybe I didn't. Yeah, okay, I was right. Yeah, I was trying to remember if I had to include this 172, but no, you do not include the 172. All right, the first stats problem was pretty easy. Here we go. All right, Alessandra flipped a fair coin 6 times, and it came up heads all 6 times. She decided to flip the coin one more time. What is the probability that the seventh flip will produce a tails? Okay, this is kind of a common misconception. So, um, you flip you flip the coin 6 times and got heads all 6 times. Okay, that's pretty unlikely, right? That's 1 in 64, 1 half to the sixth power chance that it'll come up heads all 6 times. So when you're finding the probability that it'll come up heads a seventh time, you might say, oh, that's 1/2 to the 6th, and then multiply by half again, right? Which will give you 1/128, which I believe is A. Yes, but that's actually the wrong answer, and that's because this coin it doesn't have a memory. Like it doesn't know that it just flipped heads 6 times. All it knows is that it lands heads 50% of the time. And so the probability that the seventh flip will produce a tails, well, that's just 50%. Yeah, it's just 50%. Okay. Oh my gosh, we got a three-parter. This is crazy. This is crazy. Okay. All right, use the table below for 56 through 58. Okay. So Christopher decided that he would warm up for his number sense competitions in 2023 by taking a middle school number sense test 30 minutes before the high school competition started. The table above shows the time in minutes it took him to complete the middle school warm-up tests and his scores at the six. I lost track. At the 6 high school meets he has attended so far this year. So, 56. Christopher's coach plotted the data and observed a strong negative linear relationship. His coach analyzed the data, and his statistical software generated a least squares regression line with a correlation of r equals what? Okay, we have a question from a previous question. So we haven't really started this one yet, and so I'm going to go back. Oh, what happened? Why is it so zoomed in? Okay, we have a question. It says, for the interquartile range, you had an odd number of things, so you can cancel the middle one. What if the whole data had an even amount? Would you cancel the two middle? Okay, this is what happens. So if you have two, so let's say I'm just going to use numbers 1 through 10. Hopefully this answers your question. So I have numbers 1 through 10. My median, right? I don't have a middle number because I have an odd number. I have an even number of numbers, so I don't have a middle. And so the median of this would be 5.5, right? But because I have the middle, because I have an even number, my middle is still right down the middle. Sorry, that's a really dumb way of saying that. But you see, my middle is like it's not as a number in the list, and so I don't cancel out any of them. And so my first quartile is 3, and my second quartile is 8. Does that make sense? So this gives me an IQR of 5. So if you have an even number of points in your data set, you don't cancel out anything. Hopefully that answers your question. Picked A at the competition. On which one? I don't know. Oh, at 55? Yeah, that's a rough one. Yeah, he tried to trick you. A lot of people fall for it. It's a easy mistake. I had also taken stats like the year before, and so I was ready for something like that. My teacher we had to do a project where we try to lie with statistics basically as much as possible. And basically, our grade depended on how many times we tricked the teacher. And I tried that one. He saw right through it. But yeah, that was kind of a fun unit actually. Okay, let's go back to this 56. All right. So just a reminder, we're taking a middle school test and then middle school test, timing it, finding out what the high school score would be. So give me just 1 second, so I don't have to keep referencing back. Okay. So he plotted the data and observed a strong negative linear relationship. His coach analyzed the data, and his statistical software generated a least squares regression line with a correlation of r equals what? Okay, so the only way to really do this is to just use a regression software. You can do this like just with your calculator, but the formula is really annoying, and it's just way easier to do it this way. Okay, so what you do is you go to statistics, and then stat calculations, and then either 3 or 4, it doesn't matter. It literally gives you the exact same stuff. And whenever you do this, at the end of the whole thing, it'll give you the regression like information. So my first list is just all of our times. My second list is all of the scores. So 139, 148, 153, 164, 71, 78. There you go. And when I click OK, you see it gives me an R, and it specifically asks for the R, not the R squared that it usually asks for. But the R gives you a negative 0.9967, which, yep, that's instant choice A. Sweet. It says, then number 57 says, use the data in the table above to predict his score at the next competition if he took 9.66 minutes to complete a middle school warm-up test. All right. Well, I don't know if you know this, but whenever I set up this linear regression, there was another setting when I went to type in the x's and y's that said, what am I storing the regression equation to? And you can actually scroll over here and see that it's stored at f of 2. And so I want to find the value, I want to find the predicted score if you go for 9.66 minutes. So I just type 9.66 in here, and I get a predicted score of 182. All right, finally, find the value of the residual for the data point at 11.88, 148. So the residual is basically just what's my estimated value, like what's the difference between my estimated value and my actual value. That's really what it's asking for. It's just find the error, basically. So my actual value, it tells me, is 148. But then my regression line, what would my regression line tell me at 11.88? 11.88 gives me that. And so compared that with 148, I get a residual of 2.1. Not too bad. All right, only 2 more. Maybe this will be like a paired one, so it's like so we get the rest of them done in one. It is a paired one. Oh my gosh. I got way too excited over that. All right, a researcher is testing the claim that 62% of Americans believe that the economy is the most important issue in America today. In a survey involving a simple random sample of 1,200 Americans, 782 responded by placing the economy as their top concern. The researcher performed an appropriate test with the null hypothesis of p equals 0.62 and my alternative hypothesis of the proportion is not equal to 0.62. He used a significance level of 0.05, which is, by the way, the same thing as 95% confidence. Same thing as 95% confidence. What is the value of the test statistic? So there's a lot to unpack here. First of all, our null hypothesis is that P equals 0.62, which means your null hypothesis is that the proportion of Americans that think that the economy is the most important issue is 62%, right? And we're testing that against the null hypothesis that it's not equal to 0.62. Okay? That it's not equal to 0.62. It also tells us that we sampled 1,200 people, and 782 of them said yes, this is the most important issue. And then the last thing is we have 95% confidence. Bear with me for just a second. I need to try something. I think this will work. I'm just trying to see if this will make this a shortcut. Okay, I think that worked. Let me double check. Oh, wrong thing. Aha, it could work. I wasn't sure if that was going to work. Okay, all right. So here's what you can do. There's different kinds of tests, and that's what this is trying to find out. You're testing to see if the null hypothesis is actually true, or if we have to reject it, right? So this test, we're dealing with a proportion, right? We're trying to see if this proportion is true, or if we can reject it. So this is going to be what's called a one proportion or a one prop. Oh, my pen is struggling a little bit. One prop, and then it's called a z interval. I'm a little bit fuzzy on why it's actually called a z interval, but that's the only kind of one prop interval that there is, and so you don't really have to worry about knowing which one the other one is. So if we go right here, you go to statistics, and then number 7, you see a stat tests, and let's see, you can see there's only one that's the prop, the one prop, right? There's no like one prop t test or anything. It's just one prop z test. So this is supposed to be like p naught, like our initial, like our null hypothesis, which we said was 0.62. We had 782 people agree with the statement, so that's our number of successes, and then our sample size was 1,200. And then our alternative hypothesis, right, our HA, is that the proportion, that the actual proportion is different than our null hypothesis. That's what we're trying to test if it's true or not. And it gives us this little output here. So here's our title, here's our alternative hypothesis. This is what's called the test statistic, right? This Z, this is the test statistic. It's basically like the number of standard errors or standard deviations away from your mean, right? Like if you had a test statistic of 0, that would mean like you're right on the money, like you got exactly 0.62. If you got a test statistic of like 4, that's really far out. Like you're definitely going to reject. So this is your test statistic, and this is what it's actually asking for in the question. So what's the value of the test statistic? Well, it's going to be 2.26. And it says, what was the conclusion of the researcher after studying the test results? All right, so we're either rejecting or failing to reject based on a certain p-value. So what was the p-value we got? So we got a p-value of 0.02 of point. Okay, so like what is this rounding to? Oh yeah, to the hundreds. Okay, so we get a p-value of 0.02. Well, does that mean we're going to reject or fail to reject the null hypothesis? Okay, so we can get rid of these first of all. So does that mean we reject or we fail to reject? Since 0.02 is less than the 0.05, which it gives us as the significance level for the alpha value, then that means we are going to reject the null hypothesis. Basically, this means that this 0.02, what this means is that if the null hypothesis was true, right? Say the true population is actually 62%. If the null hypothesis was true, there would only be a 2% chance of getting a value like this or this extreme, right? Hopefully that makes sense. So if you only have a 2% chance of getting that, then we can reject the null hypothesis and say, hey, this is unlikely enough that we're pretty sure that it's actually a different number. You're not saying that it's this number. You're not saying that it's like 0.652. You're just saying based on this 0.62, we can say that it's very unlikely. It's only a 2% chance that you would get this value. Okay. Hopefully all that made sense. We got the calc and stats done. If anyone has any questions, you guys can go ahead and ask. I'll stick around for a little bit. Or if you have questions, you can just text me on the Discord, if you guys would rather do that. Next time I'll be a little bit more prepared. I'll make the test a Google Drive link, and then you guys can reference the test that way. But if you guys don't have any more questions, I think we're gonna call that it. We got like right around an hour. This is pretty good timing, actually. So I'm gonna call that a wrap. All right. See you guys. Uh-oh. Oh, here we go.